the different probability of the different loads. So, and also we need to consider the important factor of the different structure. So that actually we will do the design to do the combination with the load, not only load actually, because action, because we said we have a direct action and an indirect action. Direct action meaning refer to the load, and the indirect the constraint, the temperature induced the force, something like this. So for the action, and we also can divide into three different types: permanent action, variable action, and extensional action. So from the name we can see permanent action. For this type of action, is an action that doesn't change over time or change are negligible compared with the mean value during the structure service period. So this permanent action, actually, before we call it a dead load. Dead load, that means dead load. Is that dead? Yeah. So that just like when you're dead, they just static there. There's no change. No change means the position no change, the weight no change, the force no change.
Fixed.
Yes. Position and the temperature fixed. So for this type of the action, what type of action do you think belong to permanent action or dead load? I mean, can you make example for this permanent action? What type of action belong to permanent action?
Can we use the examples from the direct and indirect?
What's that mean?
Maybe the indirect, you have the self-force, the temperature, can also be used for the permanent.
Yeah.
It's no.
Because self-weight belongs to permanent action. So besides self-weight, if there's any other load or other action, we can take it as permanent action. An idea?
For the permanent.
Yeah.
Temperature.
Temperature is temperature actually is changed very easily. Yeah, very often.
This is extra right?
How about natural conditions? Like maybe earthquake or something.
Natural condition. What's type of natural condition?
Maybe earthquake.
No. Actually, you see, some of these, suppose, this is the bridge, this is the pile, maybe this is the oil, soil, pressure of the soil. Most time actually keep the constant, or you see for the wall. Some of the you see normally if this wall and this some situation, suppose this is the roof and here got the very high slope, and then we need to building a wall to resist the this slope to keep it steady. How do you call this wall? Is well, behind this wall you get lots of soil or sand or some stone behind it. So if this wall keeps steady, actually those pressure fill the wall. Soil pressure actually is constant. Also belongs to community action. And sometimes, most time we can see the pre-stress force induced by the pre-stress. We know maybe with the time going on, the pre-stress will lose part of this pre-stress, but the main part of the pre-stress will keep unchanged. Yes.
The first stress will keep.
Yeah, we can look at the community action pre-stress force. Some of those things, the main point, the important point is that it doesn't change over time or change are negligible compared with the value. So that's the first part, permanent action, or we call it the dead load. And the second type is the variable action. And this reference value and the Peters value, we also can get by the standard value multiply some different coefficients. And this coefficient absolutely is smaller than 1. It may be 0.9, 0. Something like this. This is considered different situation because different value. So this combined value, you see this thing is making the over probability of the combined action effect coincide with the over probability of the standard value. So that means with this action maybe acting on the structure maybe just alone, we can got the probability of this action. For example, we say the vehicle. If this bridge is just open for the vehicle, then no people working there or other maybe just for vehicle. This is a very simply situation. Just the vehicle go through this bridge. But if there's beside the vehicle, we allow the people or other some animal, we can also go to this bridge. So that means the second variable load or variable action we need to consider. So as this situation, we will design then not only the vehicle but also the human being or animal, the load we need to consider. Then we need to make the combination. If you only the vehicle, there's no combination, just a vehicle, maybe plus the permanent dead load. But if not the vehicle, variable load, or not only the animal, people, we consider the wind and the water, so different, more than one, two variable. At this situation, we need to make the combination of different variable load, variable action. So that's at this station, different variable action, you need to different combination coefficient to consider the load, there's a value. And this value, you should make sure the probability of this value, this variable actually have the same probability of the standard value. So it's a little bit complicated. I'm not sure if I'm clear or not.
Yeah, it's complicated.
Doesn't matter, we just continue, and when we finish all these different this combined value, frequency value, and precise combined value, maybe we have just this magic. So we just see the second kind of the frequency value. Frequency value is the value of the total time that is exceed the design reference period, or the frequency that is exceed is limited to the value within the specified frequency. It can be expressed by the reduction of the x standard value, the frequency value coefficient. That's what. So the meaning is that when we know the standard value of the action, and we got this frequency value coefficient, we can got this frequency value. Just multiply by this standard value and this coefficient. The same things. All these different value, combined value, frequency value, and community value, we can got from the standard value. Standard value multiplied by the related coefficients. We got this different value. So for this frequency value, this time value, let's see, because when we design for let's suppose for the vehicle, actually there's lots of different types of vehicle, large, small, heavy, light, different, lots of different car. So when we design, we just in the code maybe give you a standard draw the car and the weight, the dimension of the car. Because you cannot just consider every different kind of car. We just make it simple. We use one kind of the car to represent all the car. But this standard car, of course, it is not the. If you only use this standard value, you cannot reflect the real situation, because in the real life, different car will make the truck, the bus, this is small car, and also different car. Different time, actually, it's different car, maybe action on the bridge. So this frequency value is just used to consider the most time the mean effect induced by the vehicle. For this value can reflect because not every time the car is full on the bridge, or sometimes there's no car on it. Sometimes we just one car, sometimes maybe 10 or even many cars. So you need to think. is a static probability question. There's no fixed value. So that's value actually is just to consider whether the mean situation, the mean probability, or just this word said, this sentence said, is the value of the total time that they exceeded the design reference period, or the frequency that they exceed is limited to the value within the specified frequency. Maybe this translation is poor. It's not clear.
It's confusing.
Yeah, it's confusing. Yes. In China, I'm not sure. Your Chinese, maybe in Chinese is a little bit clear.
Chinese is well.
In Chinese word, we use this. Maybe when you can see this word. It's平喻值，会不会说对现在的规定平率这个东西，还是翻译怎么能讲得清楚呢？The frequency value is the value of the total time that exceeded during the design reference period. All the frequency that they see there is limited to value. So maybe this translation is not very good. So this value we can see this is the value that is exceeded during the design period, or the frequency that is exceeded is very limited, very small. To me, yeah, this sentence is confused. This frequency value is the value relatively large. That means during the design period, maybe 100 years, this value happened very rare. Or maybe we see the value larger than this value, the value larger than frequency value, maybe only have 5% probability, or something, or 1% probability. So during that means during the design period of the structure, this frequency value is exceeded, or the value appears larger than this value. The situation is very rare, is limited. Because suppose the standard value we see the vehicle load is maybe 100 tons. Just an example. And this frequency value may be 98 tons. And because this value is just a standard value, we will design actually we don't use this value. This value is just it's based on the statistic method or also the calculation method to got this value. Because on the bridge, different car, the bus, the car, the small car, also different cars, it's very hard to define what's the value of this car. So we make a standard value, put it here, and when we design, we consider different destination, and we use different value, and this car to be multiply some of the coefficients to go to the relatively the frequency value and the combined value and different value. So for this frequency value, maybe is this the coefficient is 0.8, and we got the 98 term. For this region, during this design period of the bridge, or during this 100 years, the load larger than this or exceeded 98 tons. This region is very rare. Maybe the situation larger than this value, the probability maybe is only 40% or something like this. So because there's no fixed value, what's the probability? In Chinese explanation is just say is limited. The situation is limited. Is very rare. So that's the meaning of this thing.
The frequency reflection.
Yeah, the frequency actually is very limited, very small, very rare. You cannot. It's very hard to meet the situation. The load will be larger than this. So this is the meaning of this frequency value. So the frequency value is the value of the total time that is exceeded. Actually, the total time actually is not. It should put there. The value is the value that is exceeded the design.
I think I'll move on.
Yeah, maybe just didn't see this doesn't see the frequency that exceeded is limited to the value within the specified frequency.
When we get a book, we read. When we get a book, we read. Maybe we don't understand.
Yeah, you can see the book. But this book, I think, is not very.
No clear explanation.
Actually, I just copy the sentence on the book.
Oh, the same thing.
Yeah, the same thing. So just because the translation of the book is not good. Because this translation by the sky, yeah.
I'll actually research and read more.
So sometimes the meaning in Chinese word maybe when you translate it to English, some is not so correct. So this is the frequency value, and the third value is the quasi-permitted value. So this value is the value that the total time that exceeds during the design period, this period as a percentage of the design base period. That can be present by the reduction of the. So this value compared to this value is relatively smaller. So this value is during the 100 years of design period. This value, most time this value is the load is larger than this value. So that's value quasi permitted value. That means this value is smaller than the mean value and the mean time. So this value is you often, you just Yeah, this the coefficient. Actually, we got this. This is right there. For this quasar community, we got this coefficient phi q, and for the frequency, when we got this phi f, and for the combination, we got this phi c. Given the coefficient, multiply the standard value, we got the corresponding value, phi c, f, q. Use the first word, frequency, the quasar standard, and the combination value. So that's the different value of the variable action. So the basic thing is the standard value. And from the standard value multiplied by the combination coefficient or the frequency coefficient or the quasar community coefficient, we got this different value. So this is the second value of the variable action, and the third is the action accidental action, singular effect. Take design value as its representative value, which can be accordingly determined by historical record, observation, and test combined with the comparative analysis. So, because like an earthquake, there's actually every time an earthquake is different. So, how to calculate, how to determine what's the value of the earthquake. So, it's just determined by the historic record. Yeah, now people do the analysis of the earthquake. Just use some of the record earthquakes, the wave, give the recorder to do the analysis. The representative value of the seismic action is a standard value. The standard value of the seismic action should be defined according with the character code for this. So we got the special code for the seismic engineering for the array. And the design value of the action should be standard value or the combined value of the action multiplied by the corresponding action component coefficient. So the partial coefficients can be found in the code, related to the regulation code. So this what's the mean? This sentence. Design value should be the standard value or the combination value of application multiplied by the corresponding action component coefficient. So here, because another coefficient is a component coefficient. So beside this fancy diagram, AQ, we got another coefficient to get this design value. So it's a coefficient plot that later on we will see the formula. You will see use the formula because many different coefficient symbol. So the representative value of the action, when design the high weight bridge and the covered, it should take into account the effect that may occur at the same time on the structure. The combination of the load capacity, limited state, and surface limited state should be designed according to the following principle. So here we see during the design, you need to consider the loading carry capacity limited state And also you consider serviceability limit state, the two limit states. So do you remember what's the difference of these two different limit states? They all limit state, but what's the difference? Load capacity limit state and the service limit state. What's the difference?
The range at which the structure is used at, like the usage. The range.
The range?
Yeah.
No, exactly.
And load capacity is the how do I even say like the ability of the time. I don't know if it's the time the range that fits the ability you can hold the load. That's the load capacity, right? And the serviceability is the time which you can use.
Yeah, something like this. So the load capacity mainly refer to the situation, to the limit. Once this limit state is exceeded, this structure may be just destroyed. But for the serviceability, it's just means the large deformation, large crack, or large stress. The structure may be still okay, still can stand there, but it cannot use normal use. So this two different limit states. During the design, you need to consider these two limit states. The first one mainly refer to the safety. The second one refer to the durability or probably adaptability or yeah. So this load capacity related to the largest maximum load. Serviceability related to the large deformation, large crack walls, or the stress of the section. So during this design, we need to consider both these two limit states. Not only safe is enough. You need to make it have a good work serviceability, good working conditions. So we should have a break.
We can break now. It's 3:20.
3:20. Yeah, no. Well, according to the schedule, when should we have break? It's, we start at 2:20 and 45 minutes, so 3:05 we should have.
We should have had break at 35. That is 3.
Oh yeah, doesn't matter. Just always we have time to have break. So we use the most unfavorable. So you mean the most unfavorable combination? What's the meaning of this most unfavorable? So because you see, we still make an example of bridge. We have different variable loads: car, the wind, the water, the people, different variable loads. Maybe sometimes maybe only 1 or 2 variable, or sometimes maybe 3 or 4, 5 different. But this have a lot of situation. You have lots of different combination, and all this combination you can make a compare the value of this combination. You will find one of the most the value is the largest or the most, that means the most unfavorable to the structure, because the value, the load is larger to the structure is the more dangerous. That means the most unfavorable. So that means when we do the design, we need to select the most unfavorable combination to see, because for those different variable loads, variable action, you can make a lawful combination. Because when this variable action appear, maybe another one doesn't appear, or it can appear or it doesn't appear. So that means you have two combinations. But add another variable, say we got maybe 10, 20 different, lots of different combinations. So among this combination, which one should they use for the design? Of course, we should find the most dangerous one, most unfavorable one. So that's the mean. So we should make a syntax, and also say direct different directions. Because for the design, we say not only the vertical load. Sometimes we got the horizontal load, vertical to the bridge or horizontal to the bridge, different load direction. So for the combination, you also need to consider the direction of the load. So when the occurrence of the variable effect has a favorable effect on the structure. So what means favorable effect? When the variable action have a favorable effect on the structure. What's this mean? Favorable, that means this action is good to the structure. So what situation you can, for example, at what situation the action is good to the structure? Normally the action is unfavorable, but some situation is favorable to the structure. So can you example what situation should happen?
Actually, the variable effects, some are like maybe the wind. So how can they be favorable?
So for a very simple example, this apartment of the bridge. The self weight of the apartment actually is favorable to the structure because it makes this stable. Yeah. So at this region, the self weight is good. It's good to structure. It's heavier. It's good. It's more heavier. It's making more stable.
Actually, the self-weight, isn't it permanent verb? The self-weight.
Yeah.
Doesn't it?
Oh yes. If you're right, it's not a variable action. Yes. For the variable action,
Like the wind.
sometimes when most
Walking
time.
passengers. Maybe the passengers are walking.
Yeah, you're right. Some situation, the passenger load is good for for the cerebral bridge. Yeah, some not all situation. Yeah, some of the situation is good. So when the variable action is favorable to the structure, the action should not take into account. That means if it's good to the structure, we don't consider it. Because you see, normally if the variable action is unfavorable to the structure, maybe we use the positive value for the load. If this structure, if this action is favorable to the structure, we use the negative value. Maybe 100 pounds plus 120. Then if this value, if this action is favorable to the structure, we use the negative. Then if you plus this, then that means you make the total combination smaller. It's not good to the structure. So at this stage, we just negate it, just don't make it into combination. We just use the unfavorable action. So the action should not take into account. When the effect is impossible to simultaneously occur, or the effect of the combination probably is pretty low, the participation combination should not consider. So this means some of the variable action is very difficult to appear at the same time. Maybe this appear, this one appear, another one will not at the same time. Maybe just what situation will this happen? It's very difficult to make example. Some of the load, two different loads cannot appear at the same time. You're just thinking maybe I can't find this example, but you should remember this situation, these two cannot make the combination at the same time, because this is this different variable. Actually, normally this cannot appear at the same time, so you cannot make them together, make them in one combination. So when the highway bridge or the cover structure is designed according to the limit state or the bearing capacity, the basic combination of the effect of the permanent design condition and the short-term design condition should be adopted. So that means the basic combination of the effect we should use for the design of the short-term design and the permanent design condition. And this sentence is not very good. Translation is not good. Here in this sentence, the meaning is for this permanent design condition and short-term design condition, these two different conditions. When we consider these two different conditions, we should use the basic combination of the effect. So the meaning for this sentence is that, but if you see the sentence, it's confused. Yeah. But the meaning they want to say is that when we design the bridge and this permanent design condition and all the short-term design condition, we should use basic combination of the effect. Because for the combination, we got a basic combination and also have exponential combination and seismic combination. These three different combinations. So for this equation, we should use for this community design condition and the short-term design condition. We should use basic. We should use basic combination. The extension design should adopt the extension combination, and the seismic combination should apply to the seismic design. So let's answer this main thing for this sentence. Limit state action effect. So the first one is basic combination. For the limited state of the capacity, the code stipulated that the basic combination is like this. So when we're talking about here, do you still remember what's the permitted design condition? Permitted design condition and the short-term design condition. Any idea? I remember I had told this last class. Try to find it. Yeah, I think it's related to the here. Persistent state and transient state and external state. For this persistent state and the transient state, actually just now the permanent state, permanent condition and the short-term condition. Because this transient state actually is just for the construction state. It's the short-term compared with the service life. So the persistent state actually is the permanent condition. So this for this two condition, permanent design condition and the short-term design condition, we use the basic combination. For the limited state or the capacity, the bridge code, we use this formula. In this formula, you see here S is the effect of the load, including the dead load, the variable load. It's the result of the combination. So this is the exact value to do the combination. Gamma 0. Do you remember what's the meaning of gamma 0?
No.
The important factor of structure. So very important that we use 1.1. Important that we use 1.0. Just normal. It's not important. Not serious. We use 0.9. 0.9. So the most important thing is that those things in the bracket. Sigma I equal to 1 to m and gamma GIK. What does this mean? G what do you think? Gamma G, what's the meaning of gamma G? And this capital word G.
60.
Actually, this gamma GI is the component of the coefficient.
Component coefficient.
Yeah. Let's see here. Is the partial. Here they use this word partial coefficient. partial coefficient here. But before this, they use a component coefficient. So the same meaning. So gamma d, the meaning is partial coefficient of the ice permanent effect.
Or permanent effect.
Yeah.
The gamma GI.
GIK means the ice permanent effect. With the component effect, action effect normally refer to the structural gravity or the pre-stress. So the dead load, component action is unfavorable to the structure. Then this gamma GI we use 1.2. If this is favorable to the structure, this gamma Y we use 1.0. So here you see here is for the permanent action. Just now we said here, we see if this variable effect is favorable to the structure, we don't take into account. There, here, as you said, is a variable effect. But for this permanent effect, we just change the partial coefficient. With unfavorable to the structure, we use 1.2. If it is favorable to the structure, we use 1.0. This is for the dead load for the permanent action. But for the variable action, if it's favorable, we don't consider it.
Okay.
So that's the difference. Okay. And Q here is the partial coefficient of the vehicle load, including automobile impact force, central angular force. So that's a different force induced by the vehicle. So for the vehicle, not only the self weight for the vehicle, but also the friction force, or here we say the impact force. Actually, this impact force is the vertical direction. Friction force is the horizontal. The impact force, where it come from the impact force? Because the surface of the road is not so smooth. It also have some of the up down something like this, and also the wheel of the car also not so smooth. So when the vehicle goes through the bridge surface, will vibration. So the vibration will amplify the self weight. So this impact force actually is the amplified self weight of the vehicle. We normally use one of the impact factor to increase the self weight of the vehicle.
There's a breaking point. There is a stage, and it's not like this, but it is.
Okay, continue. When the load is calculated, this gamma Q use 1.4. When using the vehicle load, this coefficient use 1.8. So here you should see the mention two different loads. load and vehicle load. What's the meaning of this? Because when we design,
Oh, the vehicle load is like.
vehicle load is just the thing of the concentrated load of the one car. One standard model of the vehicle in the code. Because in the code, they make a standard model of the vehicle, maybe 150 ton the weight, and the dimension got to maybe 50 meters long and 3 meters wide, something like this, doing the standard model of the vehicle. That's the vehicle load. For this vehicle load, normally it's used to check the local position, like the plate of the bridge, the surface plate of the bridge, to check the loading capacity. But for this lane load, because in the non-circular bridge we got different lane, at the normal time of this lane along this bridge, we got lots of car. So when we do the total design of the bridge, not only the local part of the surface of the plate, if you do the total design, the whole structure, you should use the lane load. This lane load in the code is they give the model the uniform load along the lane. So that's two different load types for different use. One lane load is for the structure design. Vehicle load is for the local part design or local part check for the plate or some of the beam. Not for the total structure or the whole structure. So for this different situation, this gum Q, this partial coefficient is different than 1.4 and 1.8. So where a variable effect exceeds the vehicle load effect in the combination, the effect replaces the vehicle load, and there is partial coefficient use 1.4. So that means some situation maybe the one of the variable load is larger than the vehicle load. Most of the time, the vehicle load is the most important load during the different variable action. But maybe some situation, as you said, during the storm, flood, maybe the force of the flood is larger than the vehicle load. So at this situation, the partial coefficient for the flood is replaced the vehicle. They use 1.4 because this is the mean. At that situation, the flood is the most important variable action. Of course, at that situation, maybe there's no vehicle on the bridge. Yeah. For structure of yours designed to withstand effect, the sub-factor for this one is taken to 1.4. If this structure is special to design, maybe for some of the bridge, special for people for the walking, what's it called? There's not for vehicle, that's for people. Yeah, for this situation, this partial coefficient of the people is used 1.4. Yeah, the special structure for special load. And then QLK and QLD are standard value and design value for vehicle load. QLK and also for here QLD is a standard value or design value for vehicle load. including the automobile effect, centrifugal force, centrifugal force, and gamma G here is the partial coefficient of the G is variable actually in addition to the vehicle load. So beside the vehicle load, another maybe the wind, the water, or the temperature, some other variable, they use this gamma G. And the wind load is actually combination. Normally, actually, the wind is taking 1.1. The value, the partial coefficient use 1.1. And also here, QID, standard variable, this variable actually in relation to the vehicle. And here, they got this coefficient at 0.75. So actually, what the main thing is in this combination, different variable actually have different partial coefficients, and according to the combination, if this actually is favorable or unfavorable to the structure, and the partial coefficient is also different. All this coefficient, partial coefficient value you can find in the code, in the design code. So the only thing you need to know is when you design, you need to check what's the partial coefficient value you should use. You cannot just 1 plus 1 plus 1 plus 1 because every different variable actually have their own partial coefficient, and when you design, you need to check which value it should be. Yeah. This is for the basic combination. Besides the basic combination, we said we got another two combination: the extension combination and the seismic combination. So the second combination is the extension combination. So the permitted action standard value is combined with the variable represent value and the extension design value. So here, at least got the three value, the permitted standard value, and the combined variable represent value, and the external design value. The variable actually occur at the same time as the external effect can be used according to the observation data and the engineering appearance. This combination, we use this formula similar to this basic combination formula. So you see which one, where is the difference? S is the same, S is the effective design value. But here is the value of the external combination. The formula is the effective design value of the basic combination. Here we see A, here goes an A. The formal formula we don't have A. Here A is the design value with the extension effect. Oh, there's some of the symbol missed. Where is here. Here, the position missed this. close.
Q1,
Q, F, F1.
F1.
Yeah. This one is this
Yeah.
one here. Yeah. In the fruit coefficient of the yes. In the fruit coefficient of the